where we're going to be heading for here for a while is taking a look at some techniques that will make life easier for us when we're trying to integrate. Some of these functions can look extremely complex, but if we recognize certain patterns, such as the odd and even functions, it can become much, much easier. This is another one of those situations where this is a technique. We're going to talk about the substitution rule, and specifically we're going to talk about a use substitution that will make life a lot easier for us in taking integrals of some pretty complicated looking functions. Now there's two primary objectives here that we want to get out of these next several videos. I want to be able to use a use substitution to evaluate an indefinite integral, and actually I'm going to add to that a definite integral. So an indefinite and a definite integral. And I want to use what's known as a change of variable for a definite integral. These two are extremely closely related. So let's start off with defining what this use substitution is actually all about. So we know from the chain rule that if I take the derivative of f composed of g, so f of g of x, that's going to be equal to f prime of g of x times g prime of x. So if I take the integral of f prime of g of x times g prime of x dx, that's going to bring me back to f of g of x plus that constant of integration. So this is the basic idea behind what's commonly known as a use substitution. So the substitution rule for indefinite integrals is commonly referred to as, like I said, the use substitution. So let's let u equal g of x, where g prime is continuous on an interval that we're interested in, and let f be continuous on the corresponding range of g. Then on that interval we have f, or the integral f of g of x times g prime of x dx is actually equal to f of u du. Now this may seem very, very odd. That's because I need just a little bit more explanation. So let's work through this just a little bit here. So I'm going to take a look at a function that I'm trying to integrate, and I'm seeing f composed of g, and that's multiplied by whatever the derivative of g is, dx. So if I say, okay, let's let u equal g of x. Here's my u substitution. That would imply that the derivative of u with respect to x is equal to g prime of x. Now from there I can say that du is equal to g prime of x dx. Now think about what I just got done doing here. What I have is this thing du that I said is equal to g prime of x dx, but that's sitting right here. Here's g prime of x dx. So where that is, I could substitute in du, which I did right there. But I also said that u equals g of x. So I can get rid of the g of x and substitute in the u. And that gives me right here, f of u. Now the point behind this is that this function, f of u du, or integrating this, should be much, much easier than integrating f of g of x times g prime of x. That's the basic idea. Now, I'm going to work through several examples here, and hopefully after I get through one or two of them, you catch on, and the whole idea of use substitutions will actually start to become second nature to you.